Okay, this is our last podcast of Unit 6, and we're talking about how to find molecular formulas. And I promise this is not as hard as empirical formulas, although it does involve empirical formulas. So this is going to cover page 8. Now, I'm going to cover the top part and do questions 4 and 5A, and then I'm going to leave you to do B and C, and then I'll come back and do 6 with you, but you do not have to do 7 at all. So if you follow along with the podcast and you just get B and C done, then you can earn your stamp. So let's get started. On the top of page 8, we see this molecular formula. This is the true formula. That means that this is the way that the formula, the compound, actually exists in nature. And the only thing it gives us is this weird little math equation where it says to divide the molecular formula's mass by the simplest formula's mass, and that gives us X. But it doesn't really explain what is X or what to do with it. So first off, it says simplest formula mass, but remember, empirical formulas are the simplest formula, the most reduced formula for a compound. So all we're doing here is comparing the molecular formula, how much the real molecule weighs compared to the simplest formula, and we're getting this number X out of it. And what I think of this X is our molecular multiplier. By comparing these two masses, if X turns out to be 2, then the molecular formula is 2 times bigger than the empirical formula, and all we're going to have to do is multiply the empirical formula by 2 to get the molecular. So the molecular formula is, remember, the kind of the unreduced form of the empirical formula, or it could be the same. If it's the same mass, then it could be the same. The molecular formula could be the simplest formula, which does happen, but that's all we got to do is find some masses, divide them, and then do some simple multiplying. So it is going to involve a little bit of math, but not hard math. So let's put some steps. The best place I found was to put them at the top of the page. The first step is to find the empirical formula, and that might be given. You can already kind of see that first problem I'm going to work with you, it gives us the empirical formula. So don't worry about it. Just make sure you find it, because our step number 2 is then going to be to calculate the EFM, which is my shortened kind of version of the empirical formula mass. We're finding this bottom number that's going to go down here, and we will have to calculate that every single time. Now, it makes a little side note to locate the given MFM, the molecular formula mass, because that has to be given to you. We need that number to go on top, but you're never going to calculate it. So we're going to find one and calculate the other. Once we have them, of course, we're going to divide them, and I just kind of rewrote that same formula just a little bit shorter. We're finding that molecular multiplier by doing our molecular formula mass divided by empirical, almost said electron formula mass. And this should always be a whole number. If it isn't a whole number, or like 7.99 makes it 8, then you did something wrong. You're never going to be multiplying by a decimal. And once you have that number, then we're going to multiply by it. We're going to take the empirical formula that we already have and multiply it by X. And this is going to distribute. So I'm just going to kind of imagine I've got Na to S. I don't know. That's the simplest empirical formula. And let's say that my molecular multiplier ends up being 4. That number gets multiplied in. 4 times 2 is 8, so that's Na8. And 4 times that invisible 1 there is 4. So that would be Na8S4 for that weird little pretend problem. So just remember to distribute it to all of the elements in that formula. So once again, it seems like a lot of little steps, but each of the steps are tiny. So let's go ahead and work this first problem. I see that it's asking me for the molecular formula, so I'm going to have to find my molecular formula mass and my empirical formula mass. And here, even though it calls it the molar mass, that's M, molecular formula. Just kind of reduced that down. I'm going to put that label over here by the number. MFM does not give me the empirical formula mass, but it does give me the empirical formula. So I'm going to have to real quick add that up. 3 times carbon, and actually, okay, I just went ahead and did that because you don't need to watch me do every single step of that molar mass. So I added up 3 C's, 2 H's, and 1 O, and that got me 54.048. Side note, you'll see that this molecular formula mass is usually going to be a whole number, or it's definitely not going to have as many sig figs as we get. You technically don't need very many sig figs for this. As long as you kind of match what you got, we could do like 54, and that's fine. That's rounded to the whole number minus 2. But we might need this mass later on, so it's a good thing to get in the practice of calculating it precisely. So I found my empirical formula. I found its mass. Step 3 is to divide. My molecular formula mass always goes on top because we're going to be making this bigger. So I'm just writing this down so I get these right. So that's 216 over 54.048. And when I do that, that gets me 4. Now that's not my answer. That means that I need to take my empirical formula, which is C3H2O, and multiply it by 4. So 3 times 4 is 12. 2 times 4 is 8. And that little invisible 1 times 4 is 4. So this is the molecular formula for this compound. That's the way it really exists in nature. So, not too bad. Let's go ahead and look at the next problem. This one has a whole lot less writing. It just gets to the point. It gives us the empirical formula and that molar mass. Wait, so I'm going to go back and measure. We're going to leave it at that because I can't think. I'm going to label that and then do a real quick addition. Super quick addition. And remember, this is the empirical formula's mass. So that's my EFM. Here's my MFM. Just time to divide. And you might already start to look at this and be like, oh, 54 divided by 26. That's 2. It sure is. So 2 times that empirical formula gets me B4H10 as my molecular formula. So that's my final answer. I hope that this is pretty straightforward because now it's time for you to do these next 2 problems. And no fuss, no words in the way, just find those 2 masses of these 2 compounds and then divide this by that mass, this by that mass, and you should get a number. And it's not going to be bigger than like 6 or 7 or so. So if you get like 50 or if you get like 0.35, you're doing something wrong. But I believe in you. You can do it. I'm going to go ahead and look at 6. It asks me for the molecular formula. I'm going to key in on that question first. So I know I'm looking for my empirical formula and its mass and my molecular formula and its mass. And it says a compound with a formula mass. So that compound has this mass. So that's the way it exists in nature. So this is my molecular formula mass. And that always does have to be given to me. But I don't see an empirical formula, let alone an empirical formula mass. All I see are these grams of these individual separate elements. So this is evil because it's going to have you calculate that empirical formula first and then turn it into the molecular formula. So, like I said, this isn't that hard of a concept on its own, but a lot of times these go together. So, real quick, I'm just going to remind you what our steps are for empirical formulas. First step is going to be to find the grams of each element, and in that problem it was just grams already, so that's easy. And we're going to convert those to moles using dimensional analysis. So I'm going to be plugging that number that it gives me in the problem here and putting that molar mass from the periodic table down here. By the way, if you haven't already written this on page 7, it's a good thing to get down. Some of y'all missed that podcast. Remember that molar mass always goes opposite from 1 mole there. And so I'm going to do that with all of the grams, all of the elements that I'm given. And when I get those numbers out, I'm going to divide all of them by whichever is the smallest, and then make sure those are whole numbers. And sometimes there's some crazy rules on how to make them whole numbers, but hopefully this one isn't going to do that to us. But we should be practicing that. And whatever those numbers are, those whole numbers, are going to be the subscripts in the formula. So let's go ahead and do it. So I already labeled this earlier. It just disappeared. So I need to find my empirical formula so I can find its mass and divide by it. So I'm going to go ahead and get this first step set up. Okay, so I took the grams of each. I'm dividing them by the molar mass from the periodic table. And carbon ends up being 2.581. I'm going to try and keep it a little bit shorter than I might normally because I have so little space. So these are my three numbers. My smallest one is this. So I'm dividing all of these numbers by that top 2.581. It's important that we, from here on out, everything we do to all of them. So of course this first one ends up being 1, and the second one ends up being 2, and hey, this last one ends up being close enough to round to 1. So that's pretty nice. No multiplying, thank goodness. They are all whole numbers. So what I need to do is put those as my subscripts. Don't even have to write the ones. And that was our empirical formula. That used to be our answer when we were doing empirical formulas, but it doesn't ask for empirical. It asks for molecular. So I'm not quite done yet. I've got to switch colors though, or else I'm going to lose my spot. So this is my empirical formula. Hey, I found it. It took a little bit of time, but that's step number 1. Instead of just pointing to something, I actually had to calculate it. So now step 2 is to find the mass of this. And so it's a carbon, 2 hydrogens, and oxygen ends up being 30.026. And then my molecular multiplier takes that MFM, so that 180 number, divided by this 30 number, and that gives me 6. So I need to do that times CH2O, so that's C6H12O6. Wait a second, that's awfully familiar. That looks like glucose, and that's the actual molecule, the way that it exists. That's my molecular formula. That's the way it actually exists, but this is the simplest version of it, and all sugars have that empirical formula in common. That's their basic unit. So that's the answer to that question. A little bit longer, but it's basically empirical formula with quick little division and multiplication there. So make sure that you finished out B and C if you haven't already. I'm not stamping you unless you get those done and get those done right. So take a minute or 5 and get them done. Have a great night.